All right. So good morning, everyone. It's really nice to see you all. And I gave a talk here last time about all the new things in Kotlin that were relevant at the time. And today I'm happy to do a new talk because quite a lot of things are going on in Kotlin and around today in the world. And I've just recently tried to come down with a list of things that are happening today. And from top of my mind, I can start with Kotlin 2.2, which is around the corner. It's a new release where we stabilized a few language features, do a few library updates, a lot of tooling stuff, and so on. Also, today we have quite a few active discussions about larger language features such as statics, collection literals, and immutability, which are happening on our keep discussion in public. We also finally enabled K2 mode in IntelliJ IDEA 2025, which means that now IDE reuses parts of the K2 compiler, which was basically rewritten from scratch and performs much faster. And it means that now IDE can reuse these parts of the front-end analysis to also perform faster. And plus, we addressed a lot of technical debt and fixed quite a lot of inspections and intentions. And finally, we're ready to enable it by default in IntelliJ IDEA and soon in Android Studio as well. Also, it's been a question when we start developing Kotlin LSP, Kotlin Language Server for Visual Studio Code and other platforms. So finally, we managed to decouple part of IntelliJ IDEA so that we extracted part of the front end, which is mostly focused on the analysis, and now we can reuse it for other platforms. So right now it's closed source because we want to move fast, but it's possible to download archive, install it in Visual Studio Code, and so if you prefer or would like to try it for remote development or other stuff, you can try it and share your feedback. It's easy to find by just typing Kotlin LSP in Google. Also, today we are developing an experimental compiler API. So because we see that quite a lot of compiler plugins are used in enterprise and so on, and I'll talk about this a bit later. Also, on this note, we're also developing build tools API, which is an API layer between the compiler and build tool system, because right now we are quite focused on Gradle, but of course we are aware that people would love to use, for instance, Maven on the server side, or for instance Bazel or Bug. And if you want to have more or less the same experience, we'll have to repeat all the work, which is insane. And then if we do a fix for Gradle, it's most likely we have to port this fix for Maven, for Bazel, Bug, and which is just impossible. So this build tools API layer will allow us to just easily port these fixes among build systems, and it will enable, for instance, multi-platform support for Maven or other build systems, which we find important. For instance, for our own build system, which is called Ampere. And speaking of KMP, it's also one of the main uses that we are going to enable cross-platform compilation, which means that now if you're developing a Kotlin multi-platform application and you use Linux and you would love to emit artifacts that are also compatible with macOS, you don't have to have this machine. It's possible to use just your Linux and share artifacts without having macOS. And of course, we have news about Compose framework, which is now stable for iOS, so it's possible to write UI applications and share them between Android and iOS. And we are also working on Swift export, and we want to make another goal for GS export. So we are going to invest quite a lot of in GS, so it's easier to export things to JS and also like symmetrically consume TypeScript declarations, for instance, JavaScript declarations in Kotlin. And also like quite a lot of things like in tooling, like we moved from Fleet to IntelliJ and now have plugins for Kotlin multi-platform development for IntelliJ Android Studio. We have Compose Hot Reload, which I believe one of the greatest things that we released last year, which allows us to like quickly change logic and UI like applications on the fly without recompiling and restarting the application, which means that now it's probably was one of the like major drawbacks compared to Flutter, and I hope that it will definitely speed up the development and make the development more fun. And so on, because a lot of things of AI, which I decided not to include here because they change it all the time, but they are there as well, and of course all the things in libraries and so on. And today I'd love to start with part of this list, and of course we'll start with the language, which is the core of this list. And because we started with Kotlin 2.2, I have to mention that we stabilized 3 language features, which is like guard conditions in when with subject, it's non-local break and continue, and multi-dollar string interpolation. I've already covered them like in a few talks, so I'd like to, but I still would love to briefly highlight what are they. So first, it's guard conditions in when. Like it's we can have like a typical enum class which contains like a few enum entries. We have some sealed interface status, like which also have some classes like loading, error, and OK, which are like subclasses of the interface status. And today, for instance, in order to write some sort of render function, basically which takes the status object and checks all the branches with some conditions, we have to write some kind of this code, which is like more or less absolutely fine. But of course, we have like a lot of like repetitions here. Like we have to repeat status parameter all the time. We have to repeat status qualifier, and so on, so on. So guards, they introduce like a very small addition to the language. And today, with the like latest IntelliJ IDEA and Kotlin 2.2, there will be like a new like action point from IntelliJ IDEA if you type Alt Enter. IntelliJ will suggest you to replace this one and introduce a subject, so that we reduce the repetitions of this subject status because we like lifted up it to the when. And now it's we can use if, which is like guard condition, and use arbitrary conditions on our branches, which wasn't possible before. So on the one hand, it's just a very simple feature that reduces some boilerplate, but actually on the other hand, that we learned so far from it is that it also allows us to simplify code evolution, because what happens when we write some code? Like normally we start with a very simple when, and at some point in time we want to just slightly add a little bit of logic there, like for instance, like a small condition. And because we want to do as minimal changes as possible as developers, we just add like a new if check and also like else. It's already not that clear because the data flow and control flow of this program now a bit more complicated. You have to remember about this else, there's some nesting and so on. But what's happening next? Of course, we at some point in time, we also would love to add another branch. And we ended up with writing another if inside other branch. And because, again, we do not want to change this when with subject to use like regular when without subject, we do like a minimal change as possible. And we ended up with some code repetition because now we have the same else branches and non-trivial control flow. But with whens, with guards, like how do we approach this? With guards, we can just like add the necessary if guard without changing the control flow of the program. And we can also like clearly add an else branch which is like on the same nesting as we have as the other branches. And when it's time to add another guard to the when, we simply add like a new condition without any code repetition. So in this sense, guard conditions also allows us to just simplify the code evolution of when statements. Another feature which is quite a small one, but a very nasty one, is that it's about multi-dollar string interpolation. And the problem is that in Kotlin, we have this feature which is called string interpolation, where you can use $sign to refer to like variables, parameters of your code. And the problem with that is that when you want to use dollar just as a $sign, but not as something to refer to a variable, language doesn't have like an appropriate construct, because and it's the case, for instance, when you want to create like JSON schema and use, for instance, like $schema here, like just a simple word, not as a variable. The compiler will highlight this as a result reference, and you'll have to escape this $sign symbol somehow. But the problem is that it's actually non-trivial, because you can't use like just a backslash, because like it's a multi-dollar string and so on. And the actual workaround for this is to use this quite interesting. You can like find this on Stack Overflow, on some Reddit somewhere. Like it's, yeah, it takes time like to figure out that this actually works, but it works, and it's of course not the thing that we would love to live with. So in a while, like we tried like a few approaches, but finally at some point we found how C# actually had a very similar problem, and in general, like string interpolation it turned out to be like quite hard in programming languages, and like I don't know like probably a language which has very nice strings, because like they usually have like either problems with string interpolation or with multi-line strings or with raw strings and so on. And for instance, like you probably heard even in Java that they tried at some point to add string interpolation to the language, and they had at least I think like 3 attempts. And at some point, they were very close to the release. They have these string interpolations. You could write some prefix before string, dot, and so on. But just at the very end, they decided to remove all the design, because like it was just inconvenient to just include it to the language. So going back to this feature, so the solution that we find from C# is that you can use like again, you can start with IntelliJ, so that now it will highlight this, that you can add an interpolation prefix. And when you add this, when IntelliJ adds this interpolation prefix, it means that now such strings can start with an arbitrary $signs. And it means that, for instance, if you start your string with $signs, then now in order to interpolate your variable or parameter, you have to use $signs, not 1 but 2. And $sign is now just a regular string, and you can use it to write raw strings with $signs without any problems. So yeah, it's also in Kotlin 2.2. And the last feature, it's actually not a syntactical one. It's more like we just decided to remove one of the restrictions about non-local break and continuous. And the feature is that if you are in a for loop, so just in a sum loop, and also you are using some like inline functions like run or with or let and so on, it was impossible to use continue and break inside them. Because the idea was we like consciously decided to restrict it at some point, because we thought that we might reuse continue and break for such inline functions as repeat or for each and so on. So we thought that maybe we have some inline functions that act as for loops, and maybe it makes sense to do like continues and breaks inside them. But in the end, like now we have almost 10 years of like production experience in Kotlin, and I see that the majority of functions that they are not for loops, and it makes more sense to allow continue and breaks inside regular inline functions inside for loops. So now it's also possible to write continue and break and do like a more, and inline functions become more transparent to control flow. So that's another feature that stabilized in Kotlin 2.2. And of course, we all those features they are quite small, and that's also for a reason, because like after like K2, like our like huge investments to the new Kotlin compiler, we had to restart a lot of language design work, because at some point we decided to freeze it in order to finish the new compiler. Because when you add new features and then at the same time you're rewriting the compiler, it's like never-ending process. So we had we needed some time to restart this development, and we started with these small features. But also in Kotlin 2.2, we also introduced a few experimental or features that are in preview that you also can try, but you have to enable them via the compiler argument. And in 2.2, we also included context parameters, nested type analysis, context-sensitive resolution. We are like to improve how annotations are applied for different targets. So for instance, if you apply annotation to a constructor parameter, which is also like a val property, right now it might be a question where it actually will be applied in the JVM bytecode. Is it going to be applied to like a constructor parameter or a backing field or a property? And sometimes it's quite important for certain frameworks. Also, a few features that are already in master of the Kotlin compiler, but not in 2.2, but they will appear in 2.20. We want to finally introduce more improvements to Kotlin constructs. This is a feature that allows to tell the compiler that I want to smart cast my arguments, like for functions like require and so on. And even more, we'd like to have more information about smart cast and use it, for instance, for exhaustiveness checks. And one of the largest changes to the language is about must use return values. So at some point, we want to switch the default and say now that every function that returns a value should be consumed at the call site. Because from quite a lot of research, and including our research, like also Google tree monorepo, which includes like millions and millions of lines of code, we see that most functions that return values should be consumed at the call site. And if return values are not consumed, so they are not used, most likely it's either a bug or a code smell. When you just invoke a function and do not use its value, it's actually always a question for a reader whether is it intentional or whether it has like quite interesting side effect which is not reflected in its name and so on. So first, speaking of like context parameters, also you've probably heard about this feature because like previously it was called context receivers, but in the scope of 2.2 we redesigned it and addressed some of the problems that it had. So now it's called context parameters, which is like almost the same. And what is this feature about? So normally it happens when you have like an interface or a class like session or transaction or something with resources that has a life cycle. And this interface has some like core functionality, like we have here an interface session and the function supports, which has checks whether the, a certain language feature is enabled or not. And how can we use this? Like when we have like this session, we just use like, of course, session.supports feature, like when guards. But also, because this is a session, it's available as implicit receiver in a lambda. So like in a function like with, or when we just have an extension receiver, because it's a session, we normally do not pass it like normally like in the parameters, but so it's similar when you have like drive with resources and you have a lambda in a block. Some certain sessions like transactions, they are implicitly available. And in this case, it's slightly less clear that now we have just a top-level function that supports feature, And also the problem is that the main actor here is not a session, but actually a language feature, because what I would love to normally do is to add an extension on the language feature class, because it's the main actor, and when I inspect what can I actually do with this class, ID can also help me, because I can now like type language feature dot when guards dot and see that there is a method like is enabled, is available, and so on, which is not possible, for instance, with session, because with session I just have to know that this session has some functionality which is also works for some reason with language features. That's the connection is not clear. So today, in order to achieve this, I can use like such thing as called like member extension function. So it's an extension function on the class language feature, but it also lives in the interface. So it actually has two receivers. One is like dispatch receiver, like session, and the other like extension receiver, which is called like language feature. So now, well, with my like implicitly available session, I can like easily and like very like nicely call this function with language features dot when guards is enabled, and it's really nice. But the problem that today, like in today's Kotlin, in order to have two receivers like as we have right now, possible only for member extension functions. So it's not possible to have like a top level functions where you declare like it is a top level, which is often the case because you normally don't have the access to your core functionality when you want to add like utility functions. And this is where like context parameters can help, because with context parameters we can now declare this function is enabled as top level. We just say that now session it here operates as a context, and also now our function process also has this context which is like implicitly available for functions that also like operate with this context like function is enabled. And now the API is very clear. It's we can add use like main actor here like language feature as an extension receiver and put like necessary contexts in their signature. And just a small note that I took this example directly from our compiler, and it's just on the one hand it's quite a very like I'd say like clear and like small addition to the compiler in terms of API, but on the other hand it actually way simplifies like how it's how you can now read the code, because previously we had something to write like if context dot language version settings dot support feature blah blah blah, which doesn't matter at all, because what matters here like in terms of like business logic is whether like a certain language feature is enabled or not. And all the things about context dot language version settings is just like a visual noise that actually do not help to understand what's going on in the code. So it's really nice. I encourage you to try it, like because we hope to make it stabilize like in 2.3 or 2.4. I hope for 2.3, but some compiler folks or ID folks might not be happy about this because they have to speed up some bug fixing. But yeah, it's available in 2.2 under a compiler key. Feel free to try it. The other thing that also about context is like is the feature that is called context-sensitive resolution. And again, on the surface, it's quite simple, because when we have like an enum class or a field hierarchy, and we want to do like when over such an enum, right now we have to write like season.winter, season.spring, and use this qualifier season all over the place. But the compiler knows that in this when branches we can use only types of these enum entries, or like specific like subclasses of field hierarchy and so on, and we do not need to repeat this qualifier all the time. So now with this feature, the compiler allows us to like omit the qualifier and use like just enum entries directly. And which means that if we, for instance, take a look at the original example with guards, here we have like a few repetitions. First of all, we see that it's status.loading, while we compare status with, again, with some certain enum entry. And we know that if we compare it not with an enum entry, it's always like false, or like it's actually even like a compiler error, because when it doesn't make sense. So when you have not only whens, but you also have like comparisons like equals equals or is checks, the compiler will allow you to omit qualifiers. And the same goes, for instance, when you compare status.problem with some problem.connection. Again, problem here is an enum class, so we can omit the qualifier there. And after like a few simplifications, it's possible to omit almost all the repetitions in this code and work directly with unique identifiers. The other, again, simple extension to the language is about type aliases. So we introduced type aliases in Kotlin, I think somewhere in Kotlin 1.6 or so, but they are available only on top level. It was impossible to use them inside classes. And the reason is that at the time we were thinking, like, how should we work with generics? Should they capture the generics? Like, if you use a type alias inside a class that has a generics, should it capture it or not? And in the end, we decided that it's not, like, considering all the use cases, they shouldn't capture anything. And in future, if you decide to introduce a feature with type alias that can capture generics, it should be called inner type aliases. Like, as the same, we have like inner classes that capture like instances of the outer class and so on. And by default, type aliases, just like as regular nested classes, they are kind of static and don't capture anything. So we extended the language to introduce type aliases as well here. And at this point, you might ask, like, what is like the general direction? Because like those features might be not very connected. They're about like different stuff and so on. And here I would start with the vision of Kotlin, which is like Kotlin is the modern like application programming language enjoyed by a wide range of software professionals. So it basically means that we don't have any specific domain. So we want Kotlin to be used in like application programming languages, which means that it's those application programming code bases that tend to live like for years. It's not for like some game development, not for some modes. It's not for system programming. So it's mostly for applications that have to live and be maintained for quite some time. So it means that we prefer features around stability, safety, clarity, and so on. And we try not to add things that do like introduce a lot of implicitness to the language. They introduce a lot of cognitive load. Instead, we are trying to introduce features that will do like more like signal about some warnings, like as with like must use return values, or they can do like obvious job for you, like with smartcast and so on. And instead, in order to understand what is the direction of the language, I would love to tell you how the work is actually divided. And normally we have 3 buckets when we develop a new language feature. The first bucket is about maintenance. So maintenance is mostly about features that are existing, features that exist in the language, like type aliases, but do not support part of the use case. They were not supported like inside classes. Or features like expect actual feature, which is about they allow you to access the platform API, but they have a few limitations, and we would like to lift those limitations in order to support more cases. Or about GM interop. We have GM interop, but of course it's not ideal, and for instance, we cannot use GM name on, for instance, on open methods and so on. So it's the first bucket that we have real nice language, but some corners can be polished, and we have to dedicate some time, and because we cannot just focus on large features, because otherwise we won't be able to fix smaller things at any time. The second thing is about fixing the defaults, here it's more interesting because Kotlin, while it's still modern and we want to be the modern language, we have to address the defaults because when it was designed on the first, it was already like 15 years ago, and of course some of the things that were designed at the time were slightly incorrect or are not that relevant today. And in order to keep the language modern, we just have to fix the defaults and introduce and simplify the things that have today in the language. And of course, we also want, on the other hand, we want to see, we continuously check which features are really great in Kotlin. For instance, we see that extension functions are really nice for extending the API, or we see that Kotlin nullability is great. And because we see that they actually work out in the end, we want to double down on them. And for instance, the feature as with context parameters, it's a natural extension for extension methods because it's also extension methods, but now you can have not one extension receiver, but more and in a more convenient way. And the same about nullability and the feature like rich errors, which I will talk like a little bit later. So yeah, again, maintenance is mostly about extending existing features to more use cases. It's like introducing more smart casts, like closing some gaps for existing features like nested type aliases. It's about also graduating experimental features that we have today in the language. It's like expect actual feature that is in beta and has a few limitations. It's about Kotlin contracts that also live in the language since Kotlin 1.4, but are still in an experimental stage and they need some love because it's just not practical to introduce more and more experimental features without like either removing them or graduating them to stable. And of course, it's also like about like some small pain points as with multi-dollar string interpolation, which the feature doesn't require like a lot of changes to the language, but it's like a huge pain point without a clear workaround, and so on. With the second bucket, it's more tricky. And here we have, on our list, we have mainly three features for now. And the first thing is about named-based destructuring, which we believe it's a simpler model for components. So today, if you have a data class like speaker with properties name and topic, it's possible to destructure it and use arbitrary names at the call site. So you can use like val name title, and you can also write val title comma name. And the compiler, which means that now your property name will go to the title and topic will go to the name, which is like obviously a mistake. And this is done via like so-called operator fun components, which is over time we see that is a more complicated thing. And what we want to achieve in Kotlin is to turn this feature to be a name-based, to use named name of the properties to destructure data classes. So it means that over the time, we start with some warnings if you destructure a data class with wrong names. So for instance, if you have this val name and title, first we'll emit like ID warnings, then warnings and errors, and we'll nudge people to use the same names over time. And if you want to do some rename, it's possible to use full syntax, which is when you use val keyword inside parentheses. It will indicate the compiler that I want to use name-based destructuring, and it will check that names of the properties are the same as the names of the variables, and it will be safe to destructure such objects. And also, but we also see that position destructuring is also, it makes sense, but not for data classes, but mostly for some containers like list, where you actually destructure it via calling the get function. Because get function is already positional. It takes like just a position, like an int, and it destructures it into like certain properties. And for this case, we'll have like a new syntax which will be used, which will be presented with square brackets. The second thing that we would love to simplify in the language is around companion objects, because we see that in like in the majority of the cases, when you have a companion object, most likely you would love to just introduce just a function or a bunch of constants, and you don't actually want to. But companion objects, they actually a more complicated thing, because with companion objects you can pass them around as regular objects. You can inherit from interfaces, and the problem is that on the one hand it's nice that you can do this, but on the other hand these features have some cost. And for instance, we have to create a type for them. We have to emit a special bytecodes for the JVM, and which also affects ABI and so on and so on. While again, in most cases you don't need this. And what we see is that we would love to introduce just regular static modifiers that will act as statics. They won't create any additional ABI. And also, in order to create a static extension, today you have to have a companion object inside it. But with static extensions, it won't be necessary. It will be possible to create an extension on a class without having a companion object. And again, while it's a new feature, we see it actually as a simplification of the language, because now with the statics, we see it as a primary way to use when you want to have some constants, and companion objects will become some kind of advanced feature that is necessary only when you want to use tricky initialization or inheritance from certain interfaces. And the next thing where we also would love to switch the default is about this must use return values. So again, the idea is that we would like to require every produced value to be consumed. And a typical example here is when you use a sequence, you call some function map and then call function on each. The problem that is when you try to call this function, nothing will be printed. And the reason is that this on each is not a terminal operation, so it's lazy, and in order to call it, you have to actually call something to list, but it's not clear. And so with the feature must use return values, the compiler will now emit a warning that you actually have to use this value or invoke a terminal operation, because this is clearly an issue and you have to fix your code. And again, this is because here we want to switch the default. It will take some time because we'll start slowly with some ID warnings, then with some warnings, and then compiler errors. And our plan is to, in Kotlin 2.2, we already have this checker. And in 2.20, we are going to annotate our Kotlin standard library and our Kotlin X library, so it will be possible to enable this feature without changing anything in your code and get more warnings on potential bugs in your code when you call things from the standard library or Kotlin X libraries. So yeah, and the reason, we understand that these changes can introduce more friction because we already have quite a huge community. We know that Kotlin is used for by more than 2 million developers, which is a very a huge number. And but on the same time, Kotlin is already it's 9 years old since its first release, and some of the decisions were not very correct. And now we can see how people actually use the language. So we want to fix some of the issues, because we are committed. Kotlin is almost 10 years old, and we are committed to investing and supporting Kotlin for another 10 years and more. And what we also see is that new users and new projects will rapidly outnumber the existing ones, and we do not want for people to inherit the original issues that were made 10 or 15 years ago. And of course, our third bucket, which is about like larger features or larger changes to the language, is about doubling down on Kotlin strings. And here we have a few things. It's about, again, context parameters, which we've already talked about. It's about rich errors or error union types, value classes, collection literals, and other stuff. And we've already talked about context parameters, so here I'll just briefly highlight the other feature that we are working on today, which is called rich errors. And the idea is that we want to finally draw this line between exceptions and recoverable errors. Because one of the things that we inherit from the JVM ecosystem is that we have exceptions. Finally, but luckily we didn't inherit checked exceptions, so in Kotlin we have only unchecked exceptions, but there is no one way how to handle recoverable errors. And it resulted in a few organic ways how you can do this, and some people still use exceptions because they just know about them. Some people use Kotlin result, which is quite restricted. Some people use result from or either from libraries such arrow, and so on. And they all have some issues, and they don't have built-in support. While we know that our story with nullability is a quite successful one in terms of ergonomics and the overall type safety. So what we want to do here is we want to slightly extend our nullability system to say that now my type can not only be T or null, but also it can be T or some error. So for instance, here my function fetch user can return user object or some error, like fetch error. And my function charge can now return transaction ID or transaction error. That can also keep some metadata inside it. And when also with this feature, the same as with nullable types, I can use, for instance, safe calls. So when I call fetch user $.charge, safe calls will propagate errors to the right. And the resulting type of transaction will be transaction ID or fetch error or transaction error. Which means that now when I process this transaction, I know everything about the errors, and I can safely print whether it's an error or it's a success. The next thing is also about type safety, which is again a long-standing issue in Kotlin, and which is about immutability. And today in Kotlin we can have value classes but they can have only one parameter, which are specifically optimized. And the idea is that we want to introduce value classes that will follow value semantics. They will be allowed to have multiple parameters. And of course, normally when you have value semantics, you cannot modify your value objects because they are values, they are somewhere on your stack, you don't have identity and so on. But of course, we would love to modify them at some point because it's impossible to live with just immutable data. But the trick here is that in order to modify it, the compiler will create copies how it creates today, for instance, for data classes when you want to actually modify a data class which has only vals. But here, in order to modify your value class, the compiler will just implicitly create these withers or copy functions with for each property when you try to modify it. So on the surface, the code will look like a normal one, so you actually don't have to learn any new concepts. But under the hood, the compiler will just create implicit copies and protect you from implicit changes. And the reason we would love to have this feature is that actually every time you want to cache something and share with other people, normally it should be an immutable object. Because if you share something that is mutable and some user changes it like consciously or not consciously, it means that your cache is invalidated or can be inconsistent and can lead to some unpredictable results. Usually, typically when you have a cache, only you as an owner would love to modify it and then signal about these changes to your users. And also an important note about this project Valhalla that you've probably heard about, that is going on in Java for last 10 years, I think. So, and it seems that they are very close to release value classes as preview in a year or so, I hope. Here we don't actually rely on this on this project, because here we would love to focus mostly on semantics, so on immutability and safety, and JVM focuses mostly on performance. So JVM will give us some optimizations like scalarization, some heap flattening. So when you store like your value classes in an array, they will be stored as two properties and not in a separate object, and so on. And it's nice that so you'll be able to play with and have this more immutability. And when JVM will release value classes, we'll just be able to reuse part of the optimizations and get better performance without patching them. And also, like, one thing that might be quite controversial is collection literals. I personally would love to have this in a language, because like even if you take a look at most modern programming language, almost every language that creates today, it comes with collection literals, because it's like collections, they are part of like every standard library. It's impossible to imagine a language which doesn't like have arrays or collections or something else. And when you have such a core thing in your language, in your library, it always makes sense to have a special built-in support in terms of like syntax. And our idea is that we would love to combine this feature with statics and context-sensitive resolution. So when you like type like a square bracket, first by using like context-sensitive resolution, we know that it's like has the expected type list int, and then we can check that this list, it contains like a special operator of that will just be invoked like implicitly at the call side and convert this collection literal to like a special factory function. So today we published a KEEP. We are discussing it on the KEEP GitHub. So feel free also to share your feedback. What do you think about the syntax, about the general approach in general, whether you like it or not, and so on. So to sum up, we have three buckets. We have like maintenance, where we just fix like smaller issues, some pain points. We're trying to graduate experimental features to stable. We have the second bucket with fixing the defaults, where we want to address the existing features and replace them or simplify with simpler ones. Like we want to change positional destruction to name-based one. We want to flip the default and require return values to be consumed at every call site. And we want to kind of replace companion object with statics. And of course, we want to like double down on Kotlin strengths. Like we want to have like rich errors, which is an extension to nullable types, and context parameters. They should be there. Context parameters, which are an extension of like regular extension functions with one receiver, and so on. And yeah, and we discuss all these features on our like GitHub repository. So we have just keep this with proposals, and we have two links, discussions and issues, where we actually discuss it with the community. And while it's nice to have, like I mentioned, that the general vision of this is that we don't focus on specific domains. So Kotlin is not for, like, we don't focus on game dev specifically. We actually do not focus on Android, while Kotlin like is kind of dominates on Android, but we actually do not have any like specific language feature for Android specifically. And the same goes for server side and other domains. The question is like, how do we actually can like address specific domain needs, because they're always there? And the answer that we follow is that we want to use compiler plugins for that. And we see that works more or less fine. Like for instance, for Spring, for server-side development, we have like all open and no arc plugins that you might that you probably use, maybe implicitly or not, because they are enabled by default, where you enable like Kotlin, Spring, Gradle plugin. Like for data frame plugin for data processing, we have like a separate plugin that allows you to change like on the fly type safe schema. Like for Android, we have Compose compiler plugin, which also like it's just a huge compiler plugin, but it's not in the language. Just like, it's close to it, but it allows us to enable declarative UI development. And we have like a compiler plugin for Gradle, which is a small one, but it's actually introduces like a nice like improvements for quality of life. It changes like previously, if you remember, like maybe 2 years ago, if you had like a property, you had to invoke .set every time. But at some point, together with the Gradle team, we decided to provide this assign operator, so you don't have to use .set every time. You can use just equals. And of course, we also see like quite a lot of plugins that are used inside enterprise that are not public, and but some of them, when we try to discuss with people whether they can make them public, because it can be beneficial for the whole Kotlin community. And for instance, that happened with such plugin as Power Assured, which can, like when you use like a short function, it can show the specific diagrams of the expression that you used in the short expression. And today we also see that AI is another domain that we love to address. And we also, like secretly speaking, experimenting with a few compiler plugins, like for some persistent prompts and so on. And the cool thing is that we do not have to change the language. We can just use compiler plugins to extend it a little bit to see whether it works or not without disrupting, because domains can be changed. They can be relevant today, and some of them might not be relevant like tomorrow. And so if you have idea how to extend the language, you can try to use compiler API. The only problem is that we do not have a stable compiler API or good documentation. So, and the reason is that with the K1 plugin, K1 compiler, like we knew that we will rewrite most of this stuff, and we just weren't ready to commit to have like stable compiler API. But with the K2 compiler, which is we're getting sure about the compiler internals, and now we're experimenting with a stable compiler API, mostly for the front-end part. So it will allow you to add the custom checks. For instance, if you want to check that you shouldn't call this function, or you should call this as specific parameters, it will be possible to extend the compiler easily and add it as a warning. Or if you want to do some code generation, it will also be easier to use compiler API at some point relatively soon. And that's it from my side. Thank you very much. If you have any questions, I will be here. So that's it. Yeah.
I think according to the time, you have 1 minute.
Mm-hmm.
I will just stand here, and so I think a question or two you can take.
Yeah, sure. Go ahead.
With the name-based destructuring, can you also flip the order of the parameters?
Yes, it's possible, because like now it will be the compiler will assign it according to names, and it will be possible to flip the order. Yes.
So in case you have like multiple properties in a class, you can also say I want to ignore this.
Yes, and you also can ignore like some properties which you don't want to destruct. Yeah.
And how?
Huh?
And how do you do that? Just to not declare them.
Yeah.
Okay, thanks.
There.
When I'm using the Kotlin 2.0 or higher with the Maven, I'm always getting the warning that it will degrade it to 1.9 because of the plugin doesn't support it. Will this be fixed and soon, or this will keep being like this as long as I'm using Maven?
Well, I definitely need more details because I do not know which plugin emits this warning. If you can just tell me, I can check.
It's Kotlin Maven plugin.
So it's just Kotlin Maven plugin. Yes, then it will be definitely fixed. Yes, because.
Great. I think I have to take the job to stop you guys right now. But as I said earlier, feel free to approach Mikhail during the breaks. And thank you very much for setting the foundation today.
Yeah, thank you for hearing
Thank you,
me.
Mikhail.